In this video, we're going to talk about power functions. A power function is just any function of the form f of x equals x to some number power, where n can be any real number. Okay, so power functions have a pretty simple form. So here are some examples of some pretty basic power functions. Here you can see f of x equals x squared. That fits the form. It's x to some number power, right? And all of these have exactly that same form. So here are 4 different power functions. And like I said, those are probably some of the simplest power functions that you can have. There are other examples of power functions which may not be so clear to you. So first, let's recall just a basic fact from algebra. If I have 1 over x to the n, so this kind of looks like 1 over a power function, that can be rewritten as x to the minus n power. So if I have a function that looks like this over on the left side, I can rewrite it in terms of x to some negative number here if n is positive. So let's look at some examples of that. So here in the first example here, I have the function f of x equals 1 over x, right? There's no exponent here explicitly, right, but it's understood to be a 1. So 1 over x to the first power is the same as x to the negative 1 power. So you can see that even though this looks like 1 over a power function, we can rewrite it in exactly the power function form by using the negative exponents. And that is something that you're going to have to do in order to use some of the upcoming rules that we will talk about in other videos. So here are just some more examples. 1 over x squared, that would be the same as x to the negative 2 power. And 1 over x cubed, the same as x to the negative 3 power. Okay, so if you have functions that look like this, 1 over x to some number power, just keep in mind that you can always rewrite those as x to some number power here by using that basic fact from algebra. Okay, so in other words, you can have power functions with negative exponents. Some other functions that might not look like power functions at first, but that actually are when you have roots in your function here. So the nth root of x to the m, that can be rewritten as x to the m divided by n power. So in other words, square root functions that look like this are actually power functions too. They are just power functions where you can have a fractional exponent. So let's take a look at some examples that look like that, and we'll go over these in a little bit more detail here. So the first example is the square root function, right? In the square root function, there's kind of 2 understood numbers in there. One in the index, right? This number here in sort of the crook of the radical sign, right? That's understood to be a 2 if there's no number here. So here there's no number, that's an understood 2. And on the x, there's no exponent, and that's an understood 1, right, for that one. And so now that I made those exponents explicit, right, it's easy using the fact that we just talked about from algebra to translate that to x to the 1/2 power. So the square root function is a power function, right? It's just a power function where the exponent is a fraction. All right, here's another example of that. Here I have the cube root of x squared, right? And so just following the algebra fact again, this is going to be rewritten, right, as a fractional exponent where the 2 is on the top and the index of the radical is the denominator of the exponent. So the cube root of x squared is the same as x to the 2/3 power. So this is a power of the form of the power function. All right, in the next example, we have 1 over, and then down in the denominator of the fraction, we have a square root. So we're going to use that fact from algebra, right, about rewriting roots as rational or fractional exponents. So the 5th root of x to the 3rd becomes x to the 3/5. Okay, and so now you can see that this is a power of x in the bottom part of a fraction. So using the first fact from algebra that we talked about, you can rewrite this as x to the negative 3/5 power. Okay, so again, this is a power function here. right, finally, the most complicated example we've looked at so far. Here I have 1 over x times the fourth root of x to the third power. Okay, so what I would do first is rewrite the radical as a fractional exponent. So the fourth root of x to the third is going to be x to the 3/4 using the second algebra fact that we had. Okay, so now here I'm multiplying some like bases, right? I have x and x to the 3/4 power. In this next step, I just explicitly put the 1 right there. Okay, and now I'm multiplying these bases out. When you multiply like bases, you add the exponents together. So x to the first power times x to the 3/4 power is going to be x to the 1 plus 3/4. So if you take the time and get a common denominator and add 1 plus 3/4, that comes out to be 7/4. Okay. So this function, the original function, is the same as 1 over x to the 7/4. Okay. And using the second algebra fact, we can rewrite that as x to the negative 7/4 power. So at first, when you see a function like this, you might not realize that this is a power function, but using the rules of algebra, right, you can rewrite it as x to some number power. That process is going to be critical in taking the derivatives of these power functions. So notice in this video there was really no calculus whatsoever. We didn't really take derivatives or do anything like that. So a lot of the work in this section will be algebraic work before you take the derivative. What we want to do is to simplify and rewrite these functions as power functions explicitly, x to some number power. And in the next video, what we will do is we'll have the power rule, which tells us how to take the derivative of a power function.